Hello everyone. So now we will learn about each of these qualities in details. So now we will start with correctness. So a program is correct when it behaves exactly as intended and no other way. So what does it mean? Like if you take a software, you cannot say that it's mostly correct, or you cannot say it's somewhat correct, or you cannot say your software is 30% correct or 50% correct. It is either absolutely correct on all possible behaviors or else it is not correct. So there is only two options. Either your software will or either your program will be correct or it's not correct. So there is nothing in between. So that's why we say correctness is an all or nothing proposition. So if you want to understand about correctness, you have to understand specifications. Correctness is related with specifications. If your specification is very bad, then it's really easy to achieve correctness. Your specification is bad, so you don't have to work much to achieve that correctness. But in practice, we don't talk about bad specification, right? We only talk about useful specification for software. So achieving correctness is always with respect to a useful specification. So now they have listed here that software is functionally correct and behaviorally correct. So they have mentioned two terms. Software is functionally correct if it behaves according to the functional requirement specification. So now what is functional requirement? So there are actually two kinds of requirement. One is functional requirement and another was is non-functional requirement. And in your project proposal, you have to list what's the functional requirement of your software. The functional requirement actually defines what a system is supposed to accomplish, what your system is able to do, what your system will do. Okay, so that's your functional requirements. It defines what a system is supposed to accomplish. Those requirements typically either satisfied or not satisfied, with nothing in between. So it could involve calculations, data manipulation, data processing, those kinds of things. Let me give you an example. Suppose a simple example. Suppose you have a software and the purpose of the software is to print a receipt after every transaction, right? So it will either print a receipt or it will not print a receipt. So that is, there is nothing in between. It will either print it or it will not print the receipt. So that's why it's a functional requirement of the software. The software is capable to print a receipt. So that's the functional requirements. And there is nothing in between. It will either print the receipt or it will not print the receipt. But what is non-functional requirements? In non-functional requirements, there is actually greater or lesser degree. So that means if you talk about ease of use of the software, it could be more easy or it could be little complex to use. So those are non-functional requirements. There is a extent to greater extent or lesser extent. So its system is not typically either usable or not usable, but may be more usable or less usable than some other system. So that's a non-functional requirement. Next one is behaviorally correct. So software is behaviorally correct if it satisfies all specified behavioral requirements. So what is behavioral requirement? It actually characterizes what a system's behavior is to be, or we can simply say it depends what the system does when it runs. So we can simply think it as a specification of user interaction, or you can simply think it as input output. What the input you are giving to the system, what is the output, what are the transition from input to output. So those kinds of things are behavioral requirements. So these requirements are usually described using use case view. So now talk about another quality. So that's reliability. So software is reliable if the user can depend on it. So when you will depend on the system, when you will see that your software including like your system including hardware and software will satisfactorily perform the task for which it was designed or intended for a specified time and in a specified environment. So here you can see there is a term specified time and specified environment. So that means reliability is actually probability of failure free operation of a complete program in a specified environment for a specified time. So from the two terms, specified environment and specified time, you can see that it actually depends on the users, when you are using it, how you are using it, those kinds of things. So reliability is actually depends on the users. So let me give you an example. Suppose a network router. So a network router averages 1 hour of failure in each 24-hour period. Suppose there is 2 failures of 30 minutes, but there is a long gap between those 2 failures. And the failure of a network router make it impossible to use some functions in the system. So now you can see the reliability of your software will depend when you are using it. Are you using it in the between of those 2 failures? So that's why your system's reliability is actually depending on the users. So the same program can be more or less reliable depending on how it is used. So now if we talk about reliability versus correctness, reliability is relative while correctness is absolute. So now you already have the idea why reliability is relative and correctness is absolute. So let me clear it. A program may be more or less reliable depending on how it is used. So we have already told you that the reliability is actually depending on the users. So a program may be more or less reliable depending on how it is used. But a program is either correct or incorrect. There is nothing in between. It doesn't depend on the users. So that's why we say that reliability is relative and correctness is absolute.